The first shortcut we're going to learn is called the power rule. So a little review. Instantaneous rate of change at any point, that's the slope of your tangent. That's your derivative. Okay? Use Newton's quotient to find the derivative of the following functions. So you would do your whole big equation, simplify it, figure it out. Ooh, I might even have the work done. So because I don't really want to do all that work right now, because I'm in shortcut mode. Here we go. Here we go. There's your derivative. Expand it. Everything cancels out nice. H goes away. Plug it in. You get 2x. Spencer, did your shortcut work for this one? Nice. Oh, you cheated? You looked ahead? Oh. Okay. He looked for a pattern. So you're going to see the pattern. Don't look ahead, but you're going to see the pattern. The answer to this one was 2x. Okay? I don't care if you're not done writing it down. You can watch the video later. So we got x cubed. You go to your formula, expand it. We did this one similarly already. Your h's cancel out. You plug in h equals 0, and you get 3x squared. Oh yeah, take pictures. Okay? So x squared became 2x. X cubed became 3x squared. X to the 4. This is now starting to be a little painful with the definition. Okay, I used Pascal's triangle to do that quickly. You still get, in an x to the 4, 5 terms when you expand it. Things cancel out, factor out your h, plug in h equals 0, and you get 4x cubed. So let's look at what happened. We had x squared went to 2x, x cubed went to 3x squared, x to the 4 went to 4x cubed. What do you think is going to happen if I did x to the 5? 5x to the 4th. How could we describe that? Well, it looks like whatever our exponent was comes out in front as a coefficient, and then our exponent goes down by 1. Whew. What about the square root of x? 1/2 is an exponent. That exponent would come out in front, and you'd subtract 1 from the exponent, and sure enough, it works for square roots as well. Whew. Now, how do you start to recognize these things is after doing a bunch of derivatives, using the derivative formula, you go, hey, wait a minute. There seems to be a pattern here. So mathematicians, and once you get to university, your university will actually get you to try to prove this. Saying, start with x to the n. Use your definition with x to the n, and prove that your answer is going to become n x to the n minus 1. And once you've done that in a general form using the definition, you can now use it as a shortcut or a formula moving forward. So, if f of x is x to the n, then the derivative, the exponent comes out in front, and you can subtract 1 from the exponent. Right? This is going to be very true. Newton's definition of the derivative, that formula, can become very tedious. Can you imagine if I had an x to the 57? Right? So if you wanted to do f of x equals x to the 57, you would just have to draw Pascal's triangle out until you got to the 57th or 58th row. Write it out, all 58 terms, only to find out they're all going to cancel except for that one, and that's our derivative. Super easy. Super fast. Question. Find the derivative. Think back. This used to take us 5 minutes. Did I shave off 4 minutes and 59 seconds? Maybe even more. How long does this take you now? If the coefficient is 1, watch this. So you're saying if the coefficient happened to be 2x cubed, you can do it quick as well. That will work.
Yes, but that's not in the formula.
Not in the formula yet. There's another thing that's coming. So yes, so far our formula only seems to work when the coefficient is 1. Okay? Okay, you're probably done. Oh. You did that one? I'm going to say, using the definition, at least 10, 15 minutes on this one. To write out all 22 terms of x plus h, at least 15 minutes. Okay? Now that's pretty powerful. Can you imagine this same lesson in a history class? Oh, you remember how that essay used to take you 10 hours to write? Today I'm going to teach you something that you can write that same essay in 2 minutes. Same bibliography, everything else the same. Yeah, plagiarism, yeah, it's called the internet. Don't tell your teacher. No, then you get in trouble. This you don't get in trouble with. Using your new derivative rules, your shortcuts, you don't get in trouble. But yes, the internet is one of those things, I guess, that could technically. But that's cheating. In math, we just teach you to be smarter than cheating. But still don't cheat, no. Sometimes you have to do some preliminary work to make it match up with the rule. So this one, f of x equals 1 over x cubed. How could I write that as a single power? You can make it to the power of -3 using a negative exponent law. Then you can do your shortcut. I'm going to tell you that in this unit, you are going to get really good at subtracting 1. It's like, what are the skills you're going to learn in this unit? I'm going to learn how to subtract 1. Test me. 7 minus 1, 6. Whew. Okay, but sometimes you're going to have trouble because you're going to have like -3 minus 1. This one is, you're going to make a mistake on this every once in a while. It's -4 is the answer, but you might be tempted to go to -2 because you're really good at 3 minus 1 to get 2. Or you could write it like this.
Excuse the interruption, staff and students. Just a couple announcements before the bell goes. We've got a...
So again, here you have f of x equals square root of x. You're going to have to change that to x to the half. Subtracting 1 skill. Now you have to do a half minus 1. Negative a half. So you could write this instead with that x to the half in your denominator. And you could rewrite x to the half as a square root. So those are all valid ways of writing your final answer. So try this one on your own. Were you able to change the form to x to the negative 4/3? And then bring the negative 4/3 in front. Subtract 1 to get negative 7/3. Again, you will get really good at subtracting 1. And you could write it like this, or like that, or like that. So there's the helpful hint at the bottom. And like you predicted already on the next page, they have rule 2, which is basically rule 1, just with a number in front. So if you'd like, you can work on the next ones before the bell goes. I'll put the answers up so you can see them on the internet later. Choom, 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 choom.